Hi, I just thought I'd put this problem in a practical context on a little video for you. I'll also put the sheets up in the site so you can use those. One of the things that people have commonly been asking for is some examples of where they might use some of these mathematical ideas contained in the Snr Math B curriculum. So here's one example that I've used many times and it worked quite well. At the back of my school, where I taught for many years, was a creek. It wasn't quite as beautiful as this one, but it certainly was an important creek in terms of the houses in the area, and kids played in it, and it was also used for a little bit of irrigation. This isn't the creek here, this is just a photo of some clip art, but it had a bridge across it at one stage, just a skinny footbridge which would have been no more than about 500 mils wide and about probably about 4 metres across. But anyway, this was a site where we investigated a realistic problem for the water board in the town where we were. The question they wanted to know is the creek healthy? And to do that, we had to work out how fast it was flowing, if it was flowing at all, and along with some of the work some of the other students did in biology, looking at what's actually in the water, our job in the maths department was to work out the flow of the creek. After doing this, the students had to prepare a report for the local water board. So what they did was, across the footbridge, they put some tape and they marked off every 20 centimetres. And then they used dipping rods, which sounds very fancy, but really it was just some doweling, a tape measure, a floater, which was just something to drop at the top of the stream to see how fast it would travel down, and some grid paper. Now from here you could think about what you need to know and what you need to do. At this point I'll give you the background. Of course we didn't give this to the kids at the time, but to investigate the flow of the creek they needed to know the area of cross-section of the creek. So to do this, as I said, they'd marked off the across the bridge in 20 centimetre intervals, and what they would do is use their droppers, which was their piece of dowels, drop them down into the creek to measure the depth as they moved across. Because what they needed to get was a picture of the area of cross-section of the creek. Once they got the area of cross-section, they could then work out the flow by dropping their floater 100 metres up the creek and determine how fast it took down, and using that they could work out the volume of water passing through the creek. Now there's a whole pile of assumptions there, not the least being that the creek is a uniform cross-section, the length of it, and these were some of the issues the students had to write about in their report. Some of them indeed tried to get measurements at different places down the creek, and it wasn't very deep. It was only about 800 mils deep at the deepest part. So some of the kids even would wade across and measure the pardon me, the depth of the creek at various parts. But the point here in a calculus unit is they used various tools they had at their things. Some of them used a trapezium rule or even Simpson's rule, or some of those rules, to try and find the area of cross-section of the creek. They then had to write up their report including these limitations as we talked about. This isn't about the creek, this is just another example we used. We got the kids to think about making gutters, and the company had to make concrete gutters, and the details there, but these gutters were used, perhaps I haven't seen them much anymore, but back when I was younger, back when I was teaching this class, these were concrete gutters which would run stormwater from the downpipe across a footpath or something and into a drain. So these were around the school when we were doing this task. So they had to make some gutters, and they had to be 1 metre long, and they had to be about 600 millimetres thick at the thinnest part. And the shape was parabolic, and you can see the questions there. So we got them to investigate what was the volume of concrete needed to make these gutters, and then we investigated could they use a different shape other than a parabola to try and define the channel to make it cheaper to make but still strong. So these are just a couple of examples of where we used calculus in contexts that were meaningful for the kids. So these were situations that were around the actual school site where we were teaching and learning. So I guess in response to your request to have more meaningful context, this is just a couple of examples. But these are from the school sites where I was working at the time. And what you've got to try and do is find some realistic and meaningful context for your students in the actual place where you are. What interests the students? What is current or topical in your site? I think I mostly got in trouble when I tried to import something from somewhere else which just didn't relate to the students that I was teaching at the time. Anyway, I hope these are helpful and look forward to engaging with you more through the rest of the unit. Thank you, bye.